Good morning, everybody. My name is Matt Sump. I'm an account executive here at ShopWare. I have Devin Glass with me here today. I'm going to cover the configuration and tips and tricks part of that, and then Devin's going to get into the Lathe 3D tools pretty in depth here today. So I have my configuration in Mastercam pretty much in the default state. I'll cover a few areas that I haven't modified from when you install Mastercam from the beginning. And then when Devin gets on later, you'll see an interface that's pretty common amongst our tech staff and what I see from a lot of customers as far as getting the system to look exactly the way that they want to. So the first thing here is I am going to share, I haven't done this on a webinar before, but they have a handout function. So I'm not sure exactly how this is going to work. And we're going to email this out to everybody in attendance and signed up. But it's just a handy PDF of all the different locations of files in Mastercam that are pertinent to your different settings. So you have your configuration file, workspace file, that's how certain things look, the toolbar file, the key mapping, which is your custom keybinds, settings for the Mastercam simulator. And then we also get into stuff if you're using the Mastercam Code Expert versus the Simco editor, where those settings are, and then as well as machine sim file locations. So all of that's in there. And it might give attendees the ability to download this right from the webinar, but like I said, we'll have this in a email follow-up after the webinar. So getting into these configuration settings, I have a list of notes here I'm going to go through. And if I go through anything too fast or you missed it, like I said, there's a recording, or feel free to answer a question, but ask a question. But there's a handful of stuff that I want to get through here, and I know we're pretty time limited. So to get to your configuration, you just click on File and then Configuration here, and it'll kick you back into regular Mastercam. Now, the first thing that I recommend customers to do, because I'm not doing it, but I'm not in a production environment, I can uninstall, reinstall Mastercam whenever I want. But the first thing I recommend to do is to create your own configuration file. So you can say Save As here, and right from the beginning, create your own config file. So it'll have the extension in there for you, but you can call it, I would call this Matt's config, or if you want to make one more at the company level to start to standardize, and then guys can go in and customize colors and stuff that's not pertinent to file locations and a couple other things that we'll get into here that's more tied into shared documents across the Mastercam setup. So you can create your own config file there. And also don't worry if you think that you messed something up or you got your config and colors into a state where you can't see anything. The nice part about Mastercam is if you just delete your config file or your toolbar file or your workspace file, the next time you fire up Mastercam, it'll just recreate those files for you. So if you feel like you've backed yourself into a corner, don't worry about it too much. I don't have these in any particular order. Mastercam did alphabetize this list on the left-hand side here a couple versions ago. So it'll be a bit hopping around in this list. The first one I want to focus on is the Start Exit tab. So the first thing here is you get to select your editor. So when you go to post a program, where's it going to? Mastercam defaults to the Mastercam Code Expert. A lot of people will switch to the Simco editor that's free, that's included with Mastercam. But if you have the paid version of Simco, mine shows up here as Simco Edit. Or if you want to use any other program, I know some customers like to use that Notepad++ program. You would just select Other here, and then it basically goes to a file browse of selecting a given executable. So whatever that executable is, whether it's, if I go to OSC drive and then go to Simco Edit, and then the Pro version here is where that Simco Edit comes from in my config, or any other program that is text editor capable. The next one here is your startup product. So a lot of people might be only a mill guy, only a lathe guy, only a router guy. you can, instead of Mastercam defaulting starting up to design, you can switch to any specific product that you want it to fire up with anytime. So that ties into the next topic I'll cover. But before I get to there, you also have your startup configuration file. So I have some customers that have asked me, I always work in metric. How do I get Mastercam to start up that way? So there's default configs for both inch and metric. So you can switch that to metric there. Then anytime you go to start up Mastercam in the future, it will default to that. One other small tip here is there is a default Mastercam file name. It's always defaulted to T. Don't ask me why, but you can put in something there different if you want. If you want to have a prefix and then start adding customer or company info after that, it can work. So that startup product I was talking about, that leads up to the next tab I was going to cover, and that's the default machines tab. So here you can select if I start up in a particular product or I load a particular product, what machine is going to pull up. Because if I hop out of my config real quick here, if I go to machine, and I have all the products here since I have a reseller license, but if I go to mill and select default, what machine and post is it going to pull? So by default, it's just going to pull the default FANUC included post that comes with any install of Mastercam. But I have a lot of customers that, they only have one, they have a C to mill and they have one CNC machine. So they could select it here and say I have a Haas vertical. So if I have my startup product as mill and my default machine as my Haas, anytime I start up Mastercam, it'll fire up in mill with my Haas post ready to go. So just eliminating a couple steps when I start my workday, for example. So since we're in the toolpath vein here and getting machines loaded, the next tab I want to cover here is the toolpath manager. So here a lot of people don't know when I load a machine, and let me get one loaded in here just so you guys can see. I'll stick with my Haas theme here. So right here you can see it says op10. So a lot of people like to do op10, op20, op30. Mastercam defaults to toolpath group in this box here. So you can set it to whatever name you want, and then what you want the delimiter to be, so a dash or a colon, whatever you want to use. And then you have the increment start, which is your first value. So that's where I get the op10 from. And then the increment value of 10. So it'll go 10, 20, 30, but you can put in any number there you want. But that's the most common from what I see out in the field. And then you also have some control here over what your NC file name is. So Devin, you might be able to help answer this for me because I think I have this different. Or Mastercam, I think, defaults to the last operations NC file. And that's where we get a lot of tech calls of people saying, I'm posting out the program, but it's spitting out two different files in my NC editor. Why is that? Well, that's because...
Well, actually, that is actually the setting we recommend. The problem that you're referring to, that comes from when they have the Mastercam file name selected, and in prior versions of Mastercam, that used to be the default.
That's it.
And what would happen is they would have the Mastercam file name called like part 1234. They get a few toolpaths written, then their coworker says, "Hey, that's not part 1234. It's 1235," and they change the Mastercam name. Now every toolpath after that is being named NC that, but that is actually a recommended setting. Okay. And they've luckily made that our default.
Thank you. So yeah, they did update that finally, because I know that was a problem for years. So that's talking about the NC file names. So a little further into toolpaths here, one below on the toolpath settings. One little small tip here, I believe Mastercam defaults to 25% of your physical memory buffering. This is just when anytime a toolpath is calculated, and I'll get in a bit to this at the very end of what I have for some additional computer tips and tricks related stuff. Mastercam is pretty conservative in that number, but a lot of people programming in Mastercam, it might be the only thing that you're doing that day or doing on your computer currently. And depending on how much RAM you have, you can bump this number up I recommend 50%. So I have 32 gigs of RAM on my laptop, so it's pulling 16 here, as that's the bridge of when it's calculating a toolpath. It has to go from the hard drive to the RAM to the processor, and then back and forth along that route, you could call it. So bumping that up from the default is handy. And then you also have these general settings preferences. And sometimes I've seen people where these are unchecked. So the multi-threading, anytime you're calculating a toolpath with the little red D icon there, so any of the dynamic toolpaths or any of the multi-axis toolpaths, they can calculate in the background. And if you have that multi-threading turned off, and you have, like I have an i7 from about 3 years ago, it has 12 threads technically. If that's unchecked, you're going to see a lot slower calculation of toolpaths. And then just some other general controls there of associativity warning messages. I've had people ask me, I'm trying to delete some wireframe that's not really tied to my toolpath, and it keeps popping up and warning me. You can uncheck that there. So the next tab here I'm going to cover is the simulation tab. And here's where you can set some tolerances. And these tolerances also will match up with some settings in the operations manager that I'll show you here in a second. Because I'll ask people, I had one customer who they were trying to use the verify compare feature down to a half of a thou or 5/10, and they weren't getting any variance in the verify compare. Well, that's because the tolerance was higher than what they were trying to compare. So if you're really trying to get some fine tuning of toolpath comparison in the simulator, you want to make sure that these values are tight enough for what you're trying to do. The only word to note here is anytime you increase tolerance, it's basically a parabolic curve on the calculation time. So you want to A, make sure that you have a computer that can handle it, and B, that it's worth what you're trying to do for that additional time that it might take. So these values are set here, but you also have control in my operations manager here. I have the simulator options, and I need at least one toolpath on there. So let me just get one here real quick. In my simulation tab here, I have, you have your tolerance setting there as well. And then on the data tab, these are the same ones that are pulled from the main configuration. So if you want to leave your configuration to the default values, that's what I was trying to get at here. You can change these for a single given file, and then it won't override all your existing files. So if you have one, tight tolerance part, you want to make sure that it verify compares properly, or simulator compares properly. You can tighten it up there as well. But that won't persist from session to session. If you do it on the configuration side, it will. We'll get into our next configuration tip here. So the next one's going to be the selection tab. So here's where you have some control over different auto cursor settings as well as general selection. And the one thing here, and this was actually bugging me, and Devin let me know about it the other day as we were reviewing what we were going to cover today. Mastercam 2021 defaults to this glow highlighting. So if I pull up a solid model here, let me see if I got just got a sample demo part that I was working on. This is just a default Mastercam demo part. But you can see here, if I'm highlighting these faces, they just highlight, or if I click on them, they look like that. Mastercam 2021, if I turn that setting on, you can see once it saves here, it does that kind of glow. And depending on the size of the face and that amount, that glow, because the glow is kind of like I'm trying to think of the best way to explain it, but it's expanding the limits of what you're technically selecting on. And so if you have really small faces, it can get really hard to pick on exactly what you want. And personally, a lot of us here are not a fan of that setting. I'm not sure why they made that default for 2021. Maybe because it looks a little fancier is about the only thing I can think of. So I definitely recommend turning that off. And then you'll get how highlighting of faces and solids looked in previous versions of Mastercam. So the next one here, and Devin helped me here too, because it's kind of a red herring. People go in here and you have your post dialog defaults. So depending when you go to post a program, what do I want to do with it? You know, do I want it to ask me what I want the NC file name to be? Do I want to open it up in my editor here? Do I want to output the NCI file, which with certain third-party tools, some people might want that. However, this is a bit of a legacy setting, and if you're using any of the newer Mastercam posts, and basically any post that's been supplied by ShopWare is going to be considered a quote-unquote newer Mastercam post, this isn't going to affect what's going to happen when you go to post out the program. So what you want to do instead, it's at the post, technically the control def level on any newer Mastercam post. So to get to that, I go to my machine tab here, and then I go, you never want to go directly to the control definition unless you're editing default operation libraries, which I don't recommend doing that very often anyway. Just save your own operation library, but that's probably a topic for a different webinar. But to change my post dialog defaults, I want to edit my machine definition first. This is just a warning saying, hey, you're affecting files that could potentially affect the code output. Just say okay. This must have been a metric file, so it loaded a metric, but doesn't matter for this example. Then you want to hit the little icon here that looks like a very rudimentary controller. And then you want to go to the Files tab. So the Files tab of your control definition, you have the post-processing dialog here. And now this is tied directly to that particular post, and you can edit it from here. So any settings you make to this window will then affect future programs. So if you always want it to overwrite, for example, instead of ask, and if you don't want it to edit, open in an editor or not, and you just want to generate the file, that's where you control it there.
And Matt, if I may jump in here, I think
sure.
the reasoning they did that, I think the reasoning why they did that in the end was the same reason why there's also a control in that configuration to say where's your default NC file location, so where does it post to default, but that also is overridden by the control definition. And I think it's the reasoning behind, let's say you have a old mill that is hooked up to an RS-232 and you just want it to send out or drip feed it right from the get-go when you hit post on that machine. But on other machines, you may not want it to immediately go into drip feed. Maybe the other machine, you can use a flash drive, whatever. You can now set it on a per machine basis. So while it is a little annoying, you have to set it on a per machine, like for every single machine, they want to give you that added control there.
Gotcha. Makes sense. Okay, so we covered the post dialog defaults. Next, I want to get into a little bit more of personal customization. So you have your colors tab here. Now, basically any color in Mastercam can be customized. I try to tell people to, really only change the ones that you want. Because if you start going down the rabbit hole of changing all these, you could start get conflicting colors, and then you might not be able to see certain things in here. But what a lot of people like to do is they like the older style where Mastercam just had a plain black background. So what you can do is change your gradient start. So say I want my gradient start to be black, and then I don't want to use any gradient background. So if I set my gradient start to black, gradient background is unchecked, and say okay, then I get to the plain black background that people are used to seeing. So that's the first one there. Then you also have like the wireframe color is down here. a lot of people, Mastercam in the newer versions defaults to this dark blue color that some people say is hard to see. And especially if you're using a black background, a lot of people like to change it to the classic Mastercam wireframe color, which is this color 10, which is the bright green. But you can really kind of just scroll through here and something to check out to see if there's anything you want to change in particular. The next tab I want to cover here is the Converters tab. So here you have control over how certain files are imported into Mastercam. And a lot of people, when they bring in solid models, they like to turn on the edge curves. So then it creates wireframe at all intersections of faces on a given solid model. So instead of having to do that every time you open up a given file, you can just set it here and then it'll do that every time. The other thing I wanted to note on this tab is exporting versions. So if you have to get files, over to a CAD system or over to a customer, just the geometry side of the file, you can default what versions you want to export them as. A common one I'll see is people want to do older versions of AutoCAD when they're saving out wireframe. That's about all I had on the Converters tab. Next is the CAD tab. So the CAD tab here, a lot of people like to not modify their line style, but by default, the Mastercam line width is as thin as it can get. And someone like me with bad eyes, I default to the thick wireframe. So I'm not using wireframe a whole lot these days, so I'm typically using it to create edge curves, containment boundaries, different ways to control tool paths or like a turn profile in Lathe. I just keep it to the thickest one, so it's just the easiest for me to see. Next is the Files tab. So the Files tab here, and I'll get into this a bit more too when I get into the how do you section of my notes here. But one thing I did want to cover here, any of these ones with the little plus icon next to the setting, it means there's a sub setting there. So the one I want to cover here is the Autosave Backup. So like any software, no software is perfect, and everyone always wants to avoid losing work if you do end up with the dreaded crash or the program just closing out or you lose power and the computer just shuts off. You can turn on this autosave setting here, and then you have some controls over how it autosaves and how often it autosaves. There's also a Mastercam Backup, and Devin, you might be able to confirm this for me, but the backup, I think, is created basically anytime you enter and exit a function, right?
No, I think it's actually when you save the file. So when you hit save, it'll create a backup of that file. So as opposed to like an undo function, it's keeping track of a previous version of that file when you hit save, and it'll keep as many. But generally, that could get very bulky depending on how many files you're working on at one given time.
I see. So if you save a file and you didn't really want to save it, you could always just go back to the backup if you have the backup turned on.
Yeah, so when you, let's say you were working on a file, you hit save, it would theoretically make a second file, and then you work on a little bit more, you hit save, it'll make a third file, and then you always have those variants.
Right, yeah, like different iterations of a given part. Okay.
Yep.
Makes sense. So that's a handy one to turn on. I'm a kind of a keyboard jockey in Mastercam, so I'm always just hitting Control S anyways to save my file. But save often and save early is what I say. The next tab I want to cover is the Screen tab. So there's some general stuff here on this tab. I don't really modify anything or recommend anything to be changed there. But people do like to, on the View tab here, people that are used to using SolidWorks like to reverse the scroll wheel. So they like to scrolling forward zooms out, which that's counterintuitive to me. Maybe it's because I've been using Mastercam for 15 years. But if you want to reverse the wheel there, and then also if you pan a lot more, say you work a lot in 2D, if you want to pan versus rotate, you have the option to switch it there as well. So that's kind of it as far as I had on just general configuration tips. Now I got this section on how do you sort of section for different settings in Mastercam. So the first one I want to cover is, I got one person saying there's no sound. You can hear me okay, right, Devin?
Yeah, I can hear you.
Okay. Yeah, for some reason you can't hear me. Or if you could respond to his question and just tell him to switch to phone. We can get it. So the first one I want to cover here is how do I customize this ribbon that's at the top of Mastercam. Anytime you're on a given tab, you can right click and say customize the ribbon here. You can also go to, at the files level, it's called options. And that'll take you to the same spot here. So I did file options there, or if I right click here and say customize the ribbon, it takes me to the same settings window. So first you have your quick access toolbar. That's these icons at the very top left. Mine are default here, but you have undo, redo, save, print. But you can add really any function you want in Mastercam up to this bar, and then you can also show it below the ribbon. So I've had guys that have been really big fans of the X versions of Mastercam with the little tiny icons. You can, if you wanted to, you could basically build the X interface via this method and show it below the ribbon bar and have all the little icons show up if you want. So the next is customizing the ribbon. And I'm not going to go into this too deep, mainly for just time constraints today. There's some other videos out there on YouTube, but basically what you can do here is you can customize any part of the interface of all these tabs in Mastercam. So you have all the default ones. So I have my main tabs here, or I can just go to tool tabs, or I can go to all tabs, and then it shows them all. But if I'm not using particular functions, I can turn them off in here. I can add to different ones. Or what I see a lot of people do is if I go to all tabs here, I can say new tab, and I can build new tabs within other ones, or I can build their own tabs by themselves. So, you know, what I've heard from the developers at Mastercam, there's close to 900 individual functions in Mastercam. Like each one of these things, like changing a solid color, or if I go to selection, like auto cursor, all those are individual functions. I can build a tab any way I want. You know, if there's 20 most commonly used functions I use, I can build a tab and call it my tab and have the things that I exactly want on the screen at all times with my tabs at the top. I'm gonna delete that guy. Oops. The next one a lot of people like to customize is the context menu. So mine is pretty close to default. The only thing I add is I add Analyze Dynamic to my right-click menu because I get a lot of solid models from customers and I got to start figuring out dimensions, how I'm going to approach programming a part for a demo. And so I just use that Analyze Dynamic a lot. But you can add any function in here, similar like the quick access toolbar. I've had people get really in the weeds on how far they customize this right-click menu. The nice part about that is if you're working on a big monitor, you don't have to go up to any toolbars at the top if you add a lot of your commonly used functions to this right-click menu. For some reason, they call it the context menu. That's why people get confused on where to find it, on how to customize it. But any command in Mastercam can be added. And you can add separators and different function sub menus within here. So like G view is a default sub menu in the right click menu, but you can get different sub menus in there if you want. Next one I want to cover here is the hotkeys. So that's on the customize the ribbon here, and then you have your keyboard shortcuts under customize. And then here you have to remember, this was turned off on mine and I was getting confused why it wouldn't pop up the other day. You have to enable ribbon access keys if you want the default hotkeys to show up. So being Windows 10 compliant, whenever Windows changed this, people that were used to using Mastercam version 9, your hotkeys were always available. But now in Windows 10, you have to hit the Alt key in order for the hotkeys to pop up. So if I'm on the Wireframe tab here and I hit Alt, it pops up with a preview of what the different the hotkeys are. So if I hit Alt here, see there's a W for line endpoint. I can hit W and then E, and then now I'm in line endpoint by just following those hotkeys there. And trying to be Windows 10 compliant, it's not as, I'm trying to think of the right word, user friendly as it might have been in old versions of Mastercam. But that's why on the customize the ribbon tab here, you have this keyboard shortcuts customize, and here you can assign any string of keys for different functions. So it'll show you if a particular function in Mastercam already has a hotkey. So like the file tab is Alt A is the current key here. But then you could do a new shortcut key, and you could do any string of keys. Like if you want it to be Control Shift something, Alt Control something, Alt Tab, although that's a Windows thing. So you have to be careful on what Windows functions are going to override particular hotkeys, or which ways you would want to set. But you have control over it, over how any hotkey or shortcut key that you would want to assign. And a lot of these default to Alt and then the thing, like I was talking about when I was going through that Wireframe line endpoint example. But different functions you can assign to Alt plus another key and then the hotkey that you want to kind of skip that little interface that pops up. So like that file location I was talking about, this is where I wanted to discuss sharing different files in Mastercam. So a very common, Mastercam installs with two directories that a lot of people might be familiar with. But if I scroll in my Windows Explorer here and go to Libraries, Documents, I have my documents, and then I have my shared or public documents that they're now called. So the My Documents includes everything in my Mastercam folder. So that's my configuration, my colors, how Mastercam looks, my key mapping, stuff like that. But what a lot of people like to share is everything that's in the shared directory in Mastercam. So all my post processors, machine and control defs, tool libraries, operation libraries, and so forth. So what you can do in here on the Files tab, you have your user data folder location, which is, My Documents, Mastercam. But then you also have a shared data folder location. So what's very common is that shared data folder is going to be a network location. And then at the IT level, they can control, do guys only have read access? Do they have read-write access? Because what a lot of customers and what I recommend is when you start really streamlining Mastercam and getting into using operation libraries, so you're not programming from scratch every file, you can get those operation files on a network drive. Everyone's pointing to that shared data folder, and then you can really start getting some standardization across the shop, on step overs, let's say for a 3D finish toolpath. So instead of having to dial all that in every time, you have proven processes that are then shared amongst all the Mastercam users in a given building. But like I said before, that Files tab where everything's located, I'll be sending that out to everybody, but then you can start defining where all these different files go and how they can be shared across the shop. And a common support call that we get, and we're happy to help you guys walk you through specific to your case on where files need to be, what sort of access they need to have in order for optimal Mastercam performance. So I just have a few more here left. The next one, let me just get a quick toolpath again here on the screen just so I can open up the Mastercam simulator. The simulator option. So if I go to simulate a given part or verify, depending on how long you've been using Mastercam, you also have control over options in here. So if I go to the File tab in the simulator and go to Options, there's just some basic things in here. There's an additional level of control over some tolerances, what you want to default for collision checking. What I do recommend is on your simulation engine here, and I set this, I believe Mastercam sets this by default, is we recommend always going with the 5-axis engine, even if you're just doing 3-axis work, and say to always use the 5-axis engine. We tend to get better performance using that. And then one other tip here is I typically recommend turning this adaptive quality off unless you have a really high horsepower computer. Because what adaptive quality, when they introduce this, basically what's that's doing is when I verify a given part, and it's just overwriting my files there because this was a new install of Mastercam for me and I hadn't updated that setting yet. But what a lot of people, that adaptive quality is basically doing this accurate zoom or attempting to do the accurate zoom all the time. And a lot of computing power is required to do that. So if you turn that off, then you can just go back to using it how it's been in the past, where if I want to zoom in on a particular area, I can click accurate zoom, and then it'll take the time to do that given calculation. So if you're seeing verify not run as fast as you're used to seeing, just make sure you go in there and turn off that adaptive quality setting there.
And Matt, if I may just pop in on that simulator engine. In previous versions of Mastercam, that was set to 3-axis. That's actually one of those settings where they kind of change their mind every 2 versions about which one they defaulted to. But in this version, if I'm not mistaken, it is defaulted to 5-axis. And the big difference between the two is the 3-axis engine is going to take liberties when it comes to displaying your part. So a circle won't be a circle, it'll be a very jagged edge. So if you've ever verified like a flat end mill going straight across the line and it looked very jagged on that wall, that was the 3-axis engine simplifying it for you and making it fast and dirty. The 5-axis engine will be faster, but it's going to take an extra step after the fact to smooth everything out to be more realistic.
Got it.
I hate that naming convention.
Right. It should be like a quality type of a name as opposed to what engine it's technically using. So that was just a couple quick tips I had on the simulator. Next here, I'm going to go into let me open up a demo file here. Just something with some 3D toolpaths on it. So all these new toolpaths in Mastercam, like I was talking about in the beginning, make sure that you have the multi-threading turned on. One thing a lot of people don't know about is if I go to my View tab here and go to multi-threading, there's a little settings icon here. And even mine the other day when I went to check this for this webinar, mine was set to number of threads as 4. And I know I have a 12-thread processor. So I switched that to 12, and I can also default the priority, which I'm going to talk about that priority a little more here in a second. I don't recommend real time. Normal is what it's going to default to. This is only going to matter if you're doing a lot of multitasking on your computer. So say you have Mastercam and SolidWorks and your email and a web browser open, playing Spotify or something like that. This will give more preference to the Mastercam calculation before it does other computing tasks that it's currently trying to do. Because even if your computer is basically idle, Windows is still doing different things in the background. So this is at the toolpath level. And if you don't know how many threads you have, what I recommend doing is going into your Windows search and type about your PC. And then it'll tell you what your processor is. So it won't necessarily tell you how many threads it has, but if you just Google your specific processor name with the word threads after it, Google the first hit will be how many threads you have. So like mine, I just Googled i7-8850H threads, and it said 12 right away. So depending on what one you have, make sure that it's set to use all of them.
Also, Matt, just to come in here, because I did do some reading on this shortly before, not the webinar, but a few weeks ago, because someone was asking about it. It turns out, according to what I read, Mastercam now in newer versions automatically searches or finds out how many your maximum amount of threads are, regardless to what that number's set as. So it should already be maxed out, but it's not a bad idea to get it to max it out in there as well.
Okay.
As your maximum threads. Theoretically, if Mastercam was able to analyze your system correctly, it should pick up on how many threads your computer has and use the maximum amount. And that acts as a limiter. Or, well, that doesn't really act as a limiter, but it'll see how many your maximum threads are and try to use that. But like I said, it's a good idea to set it there just in case your Mastercam didn't or misread your card and sell like, oh, you only have 4, 3, or 5. So still a good idea to change it, but you should be fine if you overlooked it.
Okay. All right. I just have a couple final things before I pass it over to you. I know we're running a tad long here, but I want to make sure I cover everything for everybody. Other tip I have is on the File tab here, on the Info tab, you have it's called RAM Repair File. This used to be called RAM Saver. But basically what it does is any Mastercam file, or really any program that deals with larger files, there's an underlying database that manages everything. So think of every entity in Mastercam, every piece of wireframe, every toolpath, that all has to be organized in a database so that it reads properly. And it's just a good idea, especially if you start getting into larger files or a lot of toolpaths, to run this every so often, because basically it'll optimize, repair, and reorganize the database. Think about it as when you used to do, before there were solid state hard drives, you would do the defrag of your hard disk to get everything organized and the computer would run a little faster. This is the same sort of theory in that it's just repackaging the file for future performance. And it can increase or decrease the amount of time it takes to recalculate toolpaths and just general use of a given file. Last one here in the settings is, I think I actually ran the RAM repair there, is the community tab. So if you haven't already, make sure you link your account to mastercam.com. It gives you access to the customer-only forum, the Mastercam knowledge base that has a lot of help articles in there. There's also what they call the tech exchange, which has a lot of sample files, tool libraries, different things for resources for people to use. And also, like I had in the email blast from when you guys all signed up from this, there's free Mastercam University courses, and that's the same account. So you can sign up with a free account with, say, your personal email and get access to the Mastercam University courses. But if you link your account with your license, that's where you get access to all the other things I was talking about. So since a lot of what we were talking about today was performance related in Mastercam, kind of the last tip or trick I wanted to mention is your actual computer hardware. And I know people like to, upgrade as little as you can. You don't want to be buying a new computer every year. We always try to keep up to date here on the ShopWare website. So if you go to shopwareinc.com and go to support and then Mastercam PC specs here, I try to keep this as updated as possible for what we recommend for given system specs. So if I go to, say, my premium system specs here, Intel i7, RAM, Quadro series graphics card. I actually need to update this one more time. I updated on this side, but I forgot to do it in the sub box here. But NVIDIA has a new generation called the RTX cards that was a huge leap in performance in graphics processing. I actually have a computer at home with an RTX 3090 in it, and verify times on my laptop with a P2000 graphics card versus that RTX 3090 it's 150% faster than my laptop is verifying a large file. It was such a big leap in performance. The only problem is that stock is really hard to get. But there's a whole Quadro line now of the RTX cards. So like there's an RTX 4000, and then they go up from there on the Quadro side. But even the RTX series, like the RTX 3070, 3080, 3090, is just such a large leap in performance that if you're due for an upgrade, now is probably the time to do it. Because that also ties into the new Intel processors that are coming out in the next couple months or so. Take advantage of what they call Generation 4 of the Pcie interface. So anything with a computer, you're always limited to what the slowest lane of the computer is. So for the longest time, it was RAM speeds, but now RAM speeds have gone up. The next thing was going from spinning hard drives to solid state hard drives. Well, this next leap it's called Generation 4 of the PCIe. Basically what it does is it doubles that speed. So even if you have a current solid state hard drive, going to a Generation 4 NVMe solid state hard drive, you'll see near double the performance. So the time it takes for Mastercam to open, for files to save, for files to calculate, that link in the lanes really sees a lot of performance improvement. So between the new graphics cards and the Gen 4 of the solid state hard drives, you'll see a huge leap in performance depending on how old your current hardware is. But that's my little tech weenie tip of this webinar. And if you want more specifics on that, or, I also like to tell people, you don't want to buy, if you just have 2D mill and you're not doing really large files, you don't need to go out and spend $3,000 on a computer. Feel free to reach out to myself or Austin in our inside sales. And, we're technically a Dell reseller. We do that more as a service. So if you're just looking for more specific specs to your setup in Mastercam and how you use Mastercam, we're more than welcome to recommend, very specific builds that you'll get the most bang for your buck and the most years of use out of a given piece of hardware. That was all I had. So we're going to kick over to Devin.
Okay. So as Matt was kind of talking about, we like to customize our Mastercams quite a bit. This is normally what I use when I'm not teaching. Generally, when I'm teaching, I go back to the default so everyone's on the same page. But just going to jump right into it. 3D tooling or 3D turning tools were introduced, I believe, in 2019. My goal here is to kind of talk about the importance of 3D tools, but also walk through how to make a very simple tool, then bump up difficulty a little bit, and then finish off with what I would say is a more complicated application. But first, what's the point of 3D turning tools? Well, before 2019, we were limited to 2D turning tools, basically a flat profile. Let me pull up this file of a situation came up just a couple weeks ago with a customer who they were trying to use a boring bar, and they were creating it the old-fashioned way with like 2D geometry. And if I were to look at this tool and draw the tool, it's just a 2D profile. This boring bar it's just a 2D flat profile, no depth to it, which is fine. We can program off that, no problem. I backplot it, looks fine. It's only when I go to verify it where we get into an issue, because Mastercam is trying to take liberties and trying to create that into a 3D environment. And generally, this will just look like a very blocky tool, but in this situation, it doesn't look too good. Essentially, it's revolving based on the largest diameter and then trimming away the sides, which immediately it's not right. And if I hit play and I have my stop conditions turned on with collision, I hit play here, wham. It's not going to look good. It's not going to simulate correctly. Again, I can post this out, toolpath it, and everything's fine, but to simulate it, it's going to show a bunch of collisions. On the other side of that, if I switch this out with a 3D tool, and you can see here we have a actual 3D rendering of these tools in here, so that's how you can really tell. If I switch that out, copy it to my finish pass, and regenerate them. I'll go to a top view real quick. Again, I could backplot it, I could toolpath with it just like before, but now in backplot, I have a 3D rendering of the tool. And In the verify, I have a 3D rendering of the tool. And now it's not going to show me any collisions, or if it does show me a collision, it's because maybe I whack into the shoulder here. But now I have accurate clearances, accurate inserts, and you can see here, it looks like I hit the side of the tool, which before I probably wouldn't have saw that with the 2D tool. So really, really important to use 3D tools now as they kind of get more widely accepted, and tool vendors are being more available with the 3D tools, models, I mean. So without further ado, let's jump into 3D tool creation. If you guys are ever curious about 2D tool creation, it's the same kind of, it's the same information we're inputting. It's just in a little bit of a different order. But essentially, we'll start off with something super simple. And I'm going to grab this tool 1. Now, quick note, these all came from step files that I've brought into Mastercam already. You can either import the model in before you create the 3D tool, or you can just reference the step file when you're making the 3D tool. And generally, it's not a huge deal which way you go. But when we talk about mating, you may want to import the tool beforehand, and we'll talk a little bit more about that later. But first things first, you got to bring in some kind of lathe. You got to have some kind of lathe. So I'm going to bring in a default lathe. And for you mill turn folks, it's the same deal, but just replace, when I say lathe, just say mill turn. So I'm going to bring in a lathe. Go into the tool manager. Now you got 2 windows here. You got a top window, that's your part library. So basically all the tools you're using on this part. And down here you have your tool library. Generally when I'm making a tool, both in mill or lathe, I do it in this top section. So that way if I mess something up, you know, I'm not immediately putting a garbage tool in my library. I can test it out, make sure it looks good. Excuse me, make sure it looks good, and then save it in my tool library. So I'm going to create a 3D tool by right-clicking. And I'll call it OD1. I'll call it tool 10, sure. It's a general turning. Units are inches. The next page is where I established a holder. So the first icon here is an open folder. So if I was just grabbing the straight step file, that's how I do that. The cursor is if I'm picking something that's already in this file. So that's the one I'm going to end up using. The third one is if you've created a 3D holder library. So you've imported all your holders in a holder library, and then you wanted to just reference that holder. We won't be getting into detail about that one, but that is something you can do. So I'm just going to select off the cursor, off the screen. Now it's important that you grab every piece of your holder, and that includes everything that's not cutting. So if you had like a set screw in here, you could pick that as well. If this holder was split up into pieces, you want to make sure you pick all 3 of them, because what you pick here is what's going to be used in the tool. So I'm going to just pick the holder. And it's general turning, manufacturer. I think this was a Sandvik when I got it. It's been a little while since I've downloaded it. The shank is not super important. That's more important than mill turn when you're talking about mounting it to a turret for your virtual machine simulation. So I'll just go ahead and throw the numbers in there just to be on the safe side. So I'll say thickness and then the width. Now the machine connection is the first really important part of this. And you can see here if I hover over the blank section, Mastercam's really been improving their tooltips when it comes to like imagery and description. And you can see there what it's looking for is the back of the tool. And this is essentially giving it the Mastercam the tool's bearings. So which way is back essentially. So I'm going to say select a face. I'm going to grab this back face just like it shows in the picture. So now it has its bearings of where this holder is in reference to everything else. The position of that is not super important. So if you have a holder that has maybe like a step down here, like maybe it's a Capto tool, I think is what first comes to mind, and it has like a step because it slides into another holder. You could pick that other back face. Orientation's all we care about in lathe, and then in mill turn, if I'm not mistaken, the position of that plane also comes into account when you're mounting it to the turret. Again, you can adjust it after the fact. That's not a big deal. Insert page. So in 2021, we've added the ability to have multiple inserts for a multiple inserted tool. So let's say you have a B-axis machine and you have this special tool that goes in that spindle. And if the spindle's at 0 degrees, then you're using one tool, and then if it's at 180 degrees, it's using a different tool. We have that ability now in 2021, and then we just have to tell it what angle it has to be to use that tool. And if we have time at the end, I do have one of those tools just made at one point. But we're only doing one insert, so we're just going to create a new insert. And again, I'm just going to grab a model off the screen, grab the insert. You'll see here that we only can have one model as our insert. So if for whatever reason your insert's split up into pieces, you may want to do in Mastercam before you get in here to repair that and put it back into one piece again. Generally, the insert should be good to go, and it should be in most tool vendors that I've seen. They'll have a level for cut geometry and a level for non-cutting geometry, and then you could pick them from there. And also, I didn't mention this before, but there's some optimize options, just like you would see in the model prep, optimize and repair small faces. It's also in here. So if you notice any weird model stuff happening where the edges aren't quite lining up, you can try to optimize it. General turning, manufacturer, say Sandvik. And I could put the manufacturer code if I wanted to make my life a little bit easier if that insert wore out and I wanted to order more. Next is the corner radius. And I don't know what the corner radius is, so I'm going to see if I can pick it. Luckily, I think that top is just a nice clean arc that I could pick from. And there we go, 32nd. And tool offset number 10. Home position's not super important, but basically where is the tool coming from home? So when you're verifying it or when you're backplotting it, like how far is it coming from the part? Not super important. By default, it'll use the home position on the machine, but we can say to use the home position on the tool. Now, if I were to flip this up, straight up here, and look at it as the tool's coming down, I can see that it's pointing to the right, so it's a right-hand tool. And if I wanted a quick example, I can hover over here and see the little pictures they were referenced. So it's a right-hand tool. The next page is the mating, and we have access to the align to face functions and dynamic transform in this tool. Now, this is when the insert and the holder are separate from each other. The insert's not already sitting in the holder. These tools can get the job done. The problem is, if there's another tool I want to use to get this all mated together, then I'm going to have a hard time doing it because I only have access to these. So this goes back to the whole do I import the tool first and then start making the tool, or do I just start making the tool with the step file? If you import it beforehand, any kind of mating you have to do, you get access to all the transform ops, all the model prep, align to functions that would make your life a little bit easier in that regard. I think this has been improving from year to year, and I hope to see that more of the mating tools get into the mating page of this tool designer. And a quick note about that, guys, I did say that this was from 2019. This UI might look a little bit different through these last 3 years, I believe, that this function has been around, but all the building blocks should be the same. It's just might be in a little bit different places here and there. So luckily, this is already mated for us, so I could just skip this section. I can just move on to the cutting plane. So this is one of those spots where I see a lot of people run into some issues about it, or run into issues. The cutting plane is your top reference. So your flat top reference, when this is sitting in the machine, what is the top reference here? And luckily for this tool, it'd be this face on the shank. What I've seen a lot of people do is they'll grab this and they'll mistaken this for the top of the insert. Well, you're about to see what happens when I do that. Well, I grab the top of the insert and I go to a right view. Oh, sorry, front view. You can see my whole tool's off kilter, and what I just did was I said that my top essentially is the rake angle of that insert, and that's not correct. That's not accurate. So you want to make sure that you grab a top reference. And luckily, this tool has a nice flat here. There we go. The next step is generally this tool will be like offset up or offset down. So what I call this is shimming it up. So I zoom in real close and I can see that this 2D profile that it created is not flush with the tip of the tool. So my tool is off center line. So I come over here to my offset, select the offset, grab like the midpoint of that arc. And now that's essentially shimmed the tool down so it's on center line. And this will help make sure that when you're verifying this, that the actual tool is aligned with your center line. Next page, on very simplistic tools, you don't need to do anything here. At the very most, what I've had to do is if the model is not super clean like this one is, and it has like jagged edges somewhere and the optimization didn't really help that at all, I have had to open up these tolerance before, because what will happen is if the model's really bad, you'll get to the end of the line and you'll hit the white check, and then you'll get errors saying like, hey, we weren't able to complete the boundary, something went wrong, or even sometimes it'll flat out not create a boundary in this page as you're creating it. And those situations, if you're getting boundary issues, you might just need to open up these tolerances. In prior versions, the insert tolerance in particular wasn't this low by default, so I didn't see this as much in 2020, but I do see this quite a bit in 2021 with bad models. And we'll talk about some of these other tools in here, specifically this one, adjust, when we go talk about tool number 3. Now the machine orientation. So how is this sitting in the machine? So currently it's vertical, which is, I do want it to be vertical. Top turret. Don't need to mess with the tool angle. That's only if I have like a B axis. Default active spindle left. Now I'm just going to set this to counterclockwise, which will in turn flip the tool because it knows that in order for that spindle to be counterclockwise, and for that tool to be counterclock, or the spindle to be counterclockwise, the tool insert needs to be facing down. I ran into a situation where we said that this bottom face was the cutting plane, and if you do that, then it has which way is up is down, and that gets flipped. But essentially, changing the spindle direction will be correct to what will actually be cutting. And you can see here now that the profile has turned orange instead of yellow. So orange is insert facing down, yellow is insert facing up, and that's the same deal with 2D tools. And if you've had a keen eye, what you're seeing here is we're taking a 3D model and we're building that 2D profile based off that 3D model. At the end of the day, Mastercam is still making this 2D profile to machine off of, and we're using the model as just something to verify against. So at the end of the day, this 2D profile is what's going to get us good G-code. On that topic, we go to probably the most important page out of all of this, and that is the compensation page. If you mess this up, then you're going to have a lot of issues programming and posting G-code. So first things first, I'm going to turn off the shading so we can get a better look at the profile itself. And first things first is asking us, what is the tool center? Where is the tool center in regards to this part or this insert? We've given it a corner radius, but we haven't told it where it is. So I have 3 options. I could try to use selection center, tool center. If this profile was an arc, I could theoretically grab the arc center of that, but you could see here that it's just been converted to a bunch of little tiny lines at that small of a tolerance. So that's not going to work because there's no actual center point for me to pick on. So that's a bust. What about our other 2 options? Well, we have my favorite option that I swear came out in 2021, but I also thought I saw it in 2020, so I could have just overlooked it. But essentially what you do is click on it, you grab both the side walls. So you grab this wall and this wall. And what it does is it, in the background, extends those 2 lines, creates a fillet in that corner, and uses that to find the position of that corner radius. So definitely cool. The third one is 3 points. So you draw an arc using 3 points, and it would use the corner radius that you established to place it. And then you have a fine adjust right here. So sometimes it may just be a little bit off, and I'll do a fine adjust to like move the part down, move the part up. We have our different methods of compensation. So currently it's going to be corner. So touch off on the left side of the tool, touch off on the bottom of the tool. But we also have center, where it's going to be the absolute center of the corner radius. Tip, where it's going to be centered on X, or I'm sorry, centered on Z, and then touching off on the bottom of the X. And then edge, which is very similar to corner, but it comes into play with other inserts. And you could see kind of an example of that where it has like 2 different cutting corners. We'll stick with corner. Your quadrant, generally this will have a good idea of what it needs to be from the get-go, but if this was wrong, like maybe it was set to this quadrant, theoretically, if you wanted to run with this, you'd have to touch your tool off at the tip and then subtract in Z the amount of that corner radius, which is, or actually the diameter, which would be a pain in the butt. So make sure that that quadrant is something realistic for you to touch on. And if you don't have your axis lines, it might be hard to tell what that quadrant is doing. So I'm hitting F9 on my keyboard to turn my axes back on and off. And what I try to tell people is this is literally what Mastercam is using. This is what your machine's going to be using. This is how you're going to touch it off at the machine. You're going to touch off on this left side for your Z, touch off on this side for your X. Plunge and cut direction looks good to me for this tool. Plunge is going down, cut is going across. These dang tooltips keep getting in the way. Now, this section right here is probably the most important out of all of this entire process, and it's the portion that I see a lot of people skip. You could theoretically skip this and you get cuts, but the problem is Mastercam doesn't know, if you leave this blank, Mastercam doesn't know the angle of that tool. So I believe this tool is an 80 degree. So it doesn't know how steep or how much it can plunge into a material without gouging into the sidewall of the insert. And when you get into grooving tools, this is literally what it's using to determine the width of that groover. So when you're using a groove toolpath, it would determine the step over and all that for you. So we want to be super accurate with this because this is going to help us in the long run make sure that we're not gouging into material when it comes to the sidewall. Because right now it doesn't know that these walls exist, at least toolpathing wise. So first things first is the side clearance angle, and I'm just going to get a preview of what it is. So it's basically from the Z across. So I'm going to hit the from line, grab that line. That's all well and good. But now I got to give it the length of this wall. And this you can fudge a little bit. So I usually use arc and a point. So arc and a point. It doesn't necessarily have to be on that very, very corner. You can play around with it and get it closer and closer. But generally, you know, that's fine by me to get close enough, just as long as most of the wall is being seen. The real ticket here is this angle. Same goes for the end clearance right here, and then arc and a point. Again, good to go. And really what all Mastercam cares about is this corner radius and this V formation. That's really all you need to do. That's really all you need to program using Mastercam and get good G code. But by doing this, we can make sure that Mastercam knows what that tool is capable of. So that's pretty much it. Next page is just your speeds and feeds and cooling and stuff, which we're not going to worry about, and step overs. So I'm just going to hit the white check. Actually, I'll turn the shading on before I do this. Not that that matters. White check. Looks good. I'll green check. Now we have a 3D rendering of that tool. And before I save it into a tool library, I always like to just real quick test her out. So I'll put it in top view, draw a line real quick, and do a finish pass. Using that tool. Sure. Now when I backplot it, I got a 3D reference of that tool. And it's on the line. Quick aside, just because this comes up in class quite a bit, this blue line here is not where it's making contact. That blue line is referencing the hypothetical intersection of your X and your Z of your tool. So don't be concerned if you see the blue line go past your cutting geometry or vice versa. Because if I do home, or actually I got it up, home, analyze toolpath, you can see there, it's right on the money. And from here, what I would do is, now that I see that's all good to go, I can go into Tool Manager. I could right click on it, save the tools to a library, or just click and drag it down here, which I might just do real quick. And there she is. Green check. And now that tool is in my tool library, and I can reference it in a different file. And I don't need to keep this file on hand. So I'm just going to go ahead and save this because I know you guys, I'm probably going to give you guys these files after the fact, just in case you guys want them. And we'll get on to tool number 2. And guys, I'm going to move through these tools a little bit faster and just kind of talk about the important parts. So this tool is pretty much the same deal. It's a boring bar, but what's what's different about this guy is there's no flat face for me to reference for my quote unquote top. So, you know, I'll bring in a lathe, go into Lathe Tool Manager, create 3D tool, call this boring bar, and make it like tool 11, I guess. Pick my holder. Again, pick every piece of your holder, even if it's in pieces. And I'm going to say cylindrical, grab this body. And my machine connection is the back of the tool. Just so Mastercam can get its bearings. Grab the insert. General turning, sure. Corner radius. Luckily for me, that is a radius I can pull off of. Offset number 11. It's a left-hand tool. Don't need to worry about mating because it's already mated for me. Now, here's where I was talking about here, where we're going to run into a trouble. Cutting plane. Again, if I choose the top of this insert, it's going to give me this rank angle, and the holder's not going to be nice and flat. And what I've done in the past is I've actually cut a flat onto the part to get that reference I'm looking for. But what I found in my experience of doing this is that generally when you get a tool from a tool vendor, it's already in a reasonable plane. It may not be in top per se, but it will probably be like in front. It'll be in left, right, what have you. They're not putting the tool all misaligned for you on purpose. So in this case, if I go to a top view, that's essentially what I want. A top view would be Z going up and exactly what I want. So instead of picking a face with the cursor, I'm going to say select a named plane. If I click on top, I can see a preview, and you can see that Z is going the right way. It's going up, and X and Y is going to split this sucker in half. Green check. And now if I go to a right view, it's right down the middle. Or at least it's parallel with my bore axis, or whatever you want to call it. Again, you know, Capto tools and a lot of these weird tools that don't have a flat on them, I have just put them in, or I just used a named plane, and that worked for me because the tool vendor already had it in a good view or a good plane. As long as I did rotate it before I came in here, I'm most of the time good to use a named plane. That being said, if there is a flat on it, it is is faster just to click on the face. But most of the time, a top view would work fine. And I'm just going to make sure this is all shimmed up. It looks pretty good, but I'm just going to go ahead and pick the midpoint of this arc here. And if I'm having trouble picking it, there we go. If I'm having trouble picking it, I could use auto cursor just like before, or just like other operations. It didn't really have trouble doing the boundary, so I don't need to worry about the tolerances here. Machine orientation, it's going to be horizontal. Let me get to a top view so I'm actually looking at it right. So that's all well and good, but I actually want to be counterclockwise. And actually, no, clockwise and reverse. That looks better. So the insert's facing up, but it's in that fourth quadrant. And then just like before, so I'm going to turn off my shading just so I can see it easier. Use the intersection method because, gosh dang, I like it. Fourth quadrant already picked up on. Good deal. The plunge direction, the cut direction is actually opposite of what I want, so I'm going to set it to opposite. And then just like before, my side clearance angle is from here to here. And I'll just grab arc and a point to get that kind of the wall, that length there. Same goes, other angle, and then the length, or the width in this case. And there we go. Turn the shading back on. We don't care about speeds and feeds. White check, green check, and just like before, I like to test her out. So I'll go to top view, make a new level, turn that level off, wireframe, and finish. Use that tool, and I'll just screen check. And just like before, we're right on the money. Okay. Now the last tool, I want to quickly take aside, and let me actually save this part again. So save as tool2/done. And the last tool here, before I open up the actual tool file, I want to talk about the importance of this. So in this regard, we have what's known as a face groover, and we need to face groove this part here. Let me actually make sure I'm using the 2D variant. So in the past, before 2019, what you have to do is basically call this a 2D tool, just a grooving tool of some sort. But what you'd run into is, while it would program fine, you go into the verify, and we don't get that curvature. Even though Mastercam knows this is a face groover, it doesn't know what that curvature is, so it just makes it straight. And that was a limitation of the time. So now that if I hit play, bam, it drives that holder straight into my part, even though that tool realistically in the machine is curved to make up for that. And what happened was we were just unable to verify a face groover. But now we're going to actually build a face groover and see what it does. So I'm just going to go to open here, and I'm going to do face groover, or actually tool 3. I'm going to build the tool in a different file and then just come back to this file. It's because I didn't want any junk or other geometry to deal with in here. So this is our face groover. There's a little bit of a model issue here, but I'm going to ignore it for now. Should be fine. Machine, lathe, default, tool manager, create a 3D tool, and I'll call this face groover, and call it tool 12. The holder, grab this part. And I'm getting some yellowness. It's saying that there's a problem. It detects potential issues with the model. I know that the model's not super great, so I'll try optimizing it real quick. It may not fix those issues, but I might be able to get by. Yeah, so it's still saying Mastercam has detected potential issues. Gonna ignore it for now, and we'll see if that bites us later on. I could put the shank in real quick. So the width, or the height, or I'm sorry, the thickness and the width. Good deal. Machine connection, back of the holder, just so I get the bearings. Insert page, make a new insert. And grab one from the screen, grab that guy. It's a grooving tool. And for the corner radius, now this is a situation where this solid edge is not specifically an arc. I could probably grab this arc edge or this arc face, but this is generally tapered for clearance. So the fastest solution to this problem, if you cannot actually go pick the radius, the fastest solution is to look up the tool and have that information ready when you're doing it. So you could just type in the corner radius. The second thing you could do only works about 75% of the time. And that's only if there is an actual arc on this model. If that changed at all in Z level, and that was a splined edge, we're going to have a rough time, which is what it is now, but it's so close to being arc. I'm going to do a little cheat. So I'm not going to pick the corner radius just yet. I'm still going to pick one, but not yet. So I'll give it offset number 12 and 12. That's fine. It's technically a right-hand tool. Don't need to worry about mating. Now, for my cutting plane. Again, I could just pick top, but luckily I have a top face that I can pick, so I'm just going to pick that. There we go. And I'll also grab the offset, basically shim that tool back down. There we go. And now it's created a boundary. And if luck would have it, if I go back to my corner radius page, select a corner radius, I can now pick that wireframe geometry that it created, and bam, I got my corner radius. Now that won't work all the time. Sometimes it'll just linearize it because, you know, splines are a pain to deal with. But that is a potential workaround if you don't have that information handy and it's not letting you pick it off the solid. So I'll go back to the boundary because we're not done here. And the nature of this being a face mill or a face groover is that this curvature is being picked up on with the boundary. You can see that this curvature is being picked up on the holder. And it thinks that this material is up here with basically the cutting plane, which is not true. That curvature is not going to be part of that cutting on the top there. So we need to limit its view so it doesn't think that it's colliding or that it's crashing right here on this holder. So we use this button right here called adjust to basically limit its view. And you want to be careful how far you go on this. You don't want to split your solid in half or else it'll get really mad at you. So you don't need to go crazy. That'll do. And then grab the bottom. Again, not going nuts. That should do. Hit enter to accept. It made the profile all right. And now there's like a thin blue, but should be fine. It's not taking into account this entire portion right here. And that's really the only situation that I would use that tool is for face groovers. There are like I think a couple exceptions, but face groovers is mainly what this was built for. Orientation, say it's horizontal, and that should be fine. Clockwise. Now, the important part here, now that I picked the wireframe of this, it was able to pull off the arc center of that, but maybe just to be safe, I'll arc center that portion. Looks good. Now, if I'm grabbing this corner here, then I could leave it here. I could also say quadrant 4 or switch it to edge and change the other tip, but I'm just going to leave it be. Plunge direction, cut direction is fine by me. The side clearance. So currently this is set to 0. But we want to put some information in here. So let's jump to the end clearance here for a second, because the end clearance. Oh, nope, I'm mistaken. So side clearance. So the side clearance here is going to be this angle bit. So telling it, you have clearance on that side of the tool. So arc in a point. But now this width is super important because right now Mastercam still doesn't know the width of this tool. We never at any point said how wide this tool is. Technically the angle is 0 because this isn't a cutoff tool where it might be tipped. And you can see there might be a slight rounding issue. So I'm just going to make sure that's 0. And I'm going to say that the width is between 2 arcs. So this arc and this arc. If I had that width on hand, I could have just typed that into the width, but it's telling me the width of this tool is 0.157 and some change because this model is a little bit rough around the edges. But if you had the exact number, it would pay to just throw that number in there because this is the number that it's going to use to determine its step over, to determine how it's going to finish the part. Because if you don't have that other corner, Mastercam doesn't know where that corner is, and therefore it can't finish based off of it. It can't compensate based off of it, and you're limiting yourself there, and it becomes basically a single point tool at that point. So you want to make sure that you give grooving tools the width that they require. Last page, speeds and feeds, white check, green check, green check. Now I would test this tool real quick in here, but guys, it's almost exactly the same as the part I have on my other one. So I'm just going to save this out real quick and call it done. And then we'll go to my example here to show you what this really can do for us. So I have a part here. Oop, I didn't mean to click on that one. I meant to click on this thing. And I'm going to go to Face Groover Demo Crash. And no, that is not just a bad omen. This puppy is going to crash. So this is me using that face groover, that 3D face groover. I call it 25 on this one. And I'm basically grooving out this section here. If I were to verify this guy, and you saw before the 2D tool crashes, and this one will actually show the curvature, but there's an important thing here. If I hit play, it still crashes. But this crash would actually happen in the machine. This diameter is too large for the inside radius of this tool. So this is a situation where because I went through the trouble of accurately defining the tool in Mastercam, I now know, oh, hey, if I use this tool on this diameter, I'm going to be rubbing on that shank or on that shoulder. So I could keep playing through it, but it's going to be red because every time it cuts that, it's going to be hitting this holder. On this other example, it's the same part, but I made it a little bit smaller. Generally, you just want to switch to a different tool, but this is the only face groover I have, so I'm going to just make the part smaller. So same part, just smaller in diameter. It's now within the range of that tool to take care of, and now I don't have any collisions. So by properly defining my tool as a 3D tool, I can now know its limitations and see the collision happen before it hits my machine. And like before, you just save these parts into your tool library. You don't necessarily need to hold on to the Mastercam files you used to create them, and go from there. And another quick note I forgot to mention is with 2021, what you can do here in the insert page is now tool or inserts can have multiple cutting definitions. So you could have a cutting definition for steel. You can have a cutting definition for aluminum. You can have a cutting definition for magnesium. Why not? And when you go to toolpath, you could basically right-click on the tool and say which cutting definition you want to use instead of just the default one. So that's another improvement in that regard. But yeah, that's pretty much all I had. And real quick, if I have it on hand, I think I have it talking about multiple inserts. Was it this one here? Yeah. So this is an example, just as a little extra credit. This is an example of a multi-inserted tool. So this would go into a live spindle of some sort. And depending on which insert you're using, that flips the tool around and would start using that angle essentially. So we have the ability to do multiple inserted tools. But yeah, that's all I had.
Thanks, Devin. Certainly appreciate everybody's time as usual. Like I said, I knew we'd probably run a little long today. Just the amount of topics we wanted to cover between the tips, and feel free to leave a question or a comment. Let us know. I got some ideas based on a lot of questions we had today about different graphics cards and graphics settings in Mastercam and graphics card level settings. Like I responded to the whole audience there where Brian had a question about his K220 graphics card. And you might get that warning, like I said in my answer there, that your graphics card isn't CL 1.2 compatible. Don't worry about that too much. Mastercam will still work fine. It's just with some of the newer toolpaths, specifically the 3D dynamic toolpaths and some of the multi-axis toolpaths, we can offload some of the processing to the graphics card, because there's certain functions that graphics card processors are better at computing than a regular, like your main CPU. So we're able to offload some of that and calculate toolpaths faster, which is always the goal. So I think we might do a deeper dive on computer configurations and settings in a future webinar. But again, I appreciate everybody's time, and thanks for attending, and we'll see you all around soon. Thanks, Devin.
No problem. Thanks, guys.